So let's now look at the compound interest formula as a convenient way, or much faster way rather, to calculate the future value of a lump sum. Now the compound interest formula takes this form, or this shape. It says future value is equal to the present value multiplied by 1 plus the interest rate raised to the power of n. Now you notice all the terms in the compound interest formula, the same terms we dealt with a moment ago. Future value, present value, small I, small n. So they're all the same. We've just rearranged them a little bit differently here. We've arranged them in a format where the n is an exponent. That will help us calculate the compounding part of compound interest. So compound interest is an exponential function. That's how the calculation works. So let's use this equation to solve for that same example again. So let's just fill in the blanks in this equation. Future value now is equal to $400. That was our present value, multiplied by 1 plus the interest rate, still 9% or 0.09, raised to the power of 3, because there are 3 periods. Now, when we write this equation like this, the norm is when you have a bracket, so you have 400 next to a bracket, well, that means multiply. We don't typically write the multiplication sign in there, but whenever you see a number like 400 next to a bracket, that means multiply. So if you wanted to write it down, you could put the multiplication sign in there and you'd be fine. So let's solve this equation. Well, to solve this equation, we have to think about those continuing calculation rules we looked at earlier. Well, we know we have to deal with the brackets first, then the exponent, then the multiplication. So we'll go through those steps. Well, inside the brackets is 1 plus 0.09. So 1 plus 0.09 is 1.09, and it's still raised to the power of 3, so the exponent continues on with that term. So we dealt with the brackets. The second step was to deal with the exponent, so let's deal with that. So that's 1.09 raised to the power of 3. And again, you could enter 1.09 times 1.09 times 1.09, but let's use the y to the x key just to get practice at doing that. So we would enter 1.09, the shift key, y to the x key, 3, and then equals. And look at this number 1.295. And for those of you who might remember the old mortgage tables in the back of some finance books, well, mortgage tables were factors that allowed us to calculate future values kind of by hand the old-fashioned way. That's what this number represents. It's one of those factors that you'd see in those mortgage tables. We don't have to deal with that. We've got easier ways to solve this. So it's 400 multiplied by 1.295029. So if we do that, we should get $518.11, or 1 cent rather. So a couple things to notice here. One is that this is exactly the same answer we got when we did it the long-handed way earlier, $518. So the compound interest formula is simply an easy way to find the future value of any compound interest loan, or simply finding the future value of a lump sum present value. Now in terms of your calculations, when you do this, if you've done the calculation and you've got 1.295 on your screen, well, if that number's on your screen, it's ready to be used. So the most efficient way for you to calculate this, and that 1.29 is on your screen, simply hit multiplication sign, 400 equals, and you're done. So you don't need to write all this down. We won't use that 1.295 number for any other purpose other than to achieve our future value. Okay. So that's what the compound interest formula is, easy way to find the future values, and we'll use it several times throughout these sessions. Okay. So that's simple interest, compound interest, and interest calculations. What I want to do next is talk about interest rates, specifically the kinds of interest rates that we deal most with in this course. So we'll shift over to interest rate types.